So I have just had a wee look over your answers to page 188, and in general we have done really well. I'm all the biz, and there's just a couple of mistakes that kept coming up, and to be expected. So let's go through these. So a bicycle and rider have a total mass of 90 kilograms, travel along a horizontal road at a steady speed. The force exerted by the cyclist is 40 newtons. Explain why the cyclist does not accelerate. So the frictional forces must be equal to the forward force, which is 40 newtons, or you could just say there the forces are balanced, or there's no resultant force if it's travelling at a steady speed. Now, the rider increases the forward force to 70 newtons. Calculate the acceleration. So here's my working out for it. Here's my cyclist. We now have a forward force of 70, and we know the frictional forces are 40, and we know that because I drew it on yesterday, if you remember. Let me just get on the sheet from yesterday. So whenever it was going at a steady speed, that was whenever the forward force was 40. So if it's going at a steady speed, the forces have to be balanced. That told us that the frictional forces in this scenario are 40, which meant that whenever they increased their forward force to 70, the frictional forces are still 40. Okay, so that whole spiel about the steady speed is to get you to pick up on that thing about the 40 newtons frictional forces. Okay, so this is the forces involved. What did we have to work out? The acceleration. So from this I can see that my resultant force is 30 newtons to the right, and I'm just going to put that into F equals ma. So the F, remember, in F equals ma is the resultant force. So 30 equals, the mass was 90, acceleration. So we end up, divide both sides by 90, and you get the acceleration to be 0.33, or a third. Okay, so that one was generally well done. Common mistake there is to put 70 in here. But remember, the force has to be the resultant force, and 70 isn't the resultant force because there's those 40 acting backwards. Right, question 2. A car accelerates at 3 meters per second squared along a road. The mass of the car is that, and all the resistive forces add up to 400 newtons. Calculate the forward thrust exerted by the car's engine. So here's my working out. Now, this is my working out that I did last year. I can show you a slightly different way that you can set it out if you would prefer, right? So I drew this diagram. So here's my car, there's the thrust, and there's the 400 resistive forces. So I know that has to go into F equals ma, and the F in F equals ma is the resultant force. So I put this in like this, that the resultant force is going to be the thrust minus 400 equals the mass, which is 1200, multiplied by the acceleration, which they told us was 3. So going from this line to this line, I've just tied it up. So thrust minus 400 is 3600. So then I have to add 400 onto both sides to get my thrust of 4000. Then the majority of people that did go wrong in this one, you took the 400 away from the 3600 instead of adding it on. And that might be because you set your working out differently, it might not be. The other way that you could do this one would be to just do F equals ma. Let me do it in a different colour. So you could just do F equals ma, which I think is actually the way most of you did this. That gets you 3600 newtons. And then you go back to your wee diagram and you think, right, well, the resultant of these two is 3600. So this one, if we're taking 400 away from it, has to be 3600 plus the 400 to give me the 4000. I prefer doing this, but you might prefer that way. However, doing this way does run the risk of what a lot of you did end up doing, and taking the 400 away instead of adding it on. So just be careful. Okay. 3. Calculate the force of friction on a car of mass 1200 kilograms if it accelerates at 2 when the engine force is 3000. So very similar question. I've set my working out the same way. Here's my car. We were told the thrust was 3000. We don't know what the frictional forces are. Putting that into F equals ma, the F is the resultant force. So 3000 minus the friction is equal to mass times acceleration. Mass was 1200, acceleration is 2. So this minus this gives us 2400. If I add friction to both sides and then take that away, I end up getting friction being 600 newtons. Okay, I think a lot of people did get this one who didn't get this one, and it's just the difference in the missing bit of information there, why you add one and why you subtract the other one. Okay, question 4. Figure 2.12 shows the forces on a car. So here, and it tells you its mass is 800. What direction will the car accelerate? So if we look here, the upward forces are equal to the downward forces, so they're balanced, so we can ignore those. And then our forward force is bigger than our backwards force, so it's going to accelerate to the right. Most people did get that. Now, what was strange was for part B, a bunch of people give a force as the answer whenever it asked for its acceleration. So, a bit strange. Calculate the size of the car's acceleration. So it's going to be F equals ma, and the F is the resultant force. So the resultant force is 2000 take away 400 equals the mass 800 multiplied by the acceleration. So 2000 take away 400 gives us 1600, and then we just have to divide both sides by 800 there, and you end up getting 2. So hopefully you have corrected any that you got wrong there, and then we're going to do the rest of these ones. So page 189, I just want to remind you, because this is another one where it's given us the mass and it's asking us for the weight, even though we haven't technically taught you that equation yet. Remember, the equation is weight equals mass times gravity, so you're going to use that for part A. And then for calculating the acceleration, you'll use F equals ma. Remember, the F is the resultant force, which is going to be this upward force minus the weight that's acting down the way. Okay. Right, 6 is one of these ones where they tell you about a constant speed so that you can get the frictional forces acting. Okay, so I'll give you a wee hint for it. So whenever it's going at a steady speed, a forward thrust of 300 newtons enables it to go through water at a constant speed. That means the frictional forces are 300 newtons. The speedboat has a mass of 500. Calculate the thrust required to accelerate. So now it's accelerating at 2. So the thrust is what we need, and the frictional forces will be 300. So that is going to be very like question 2 from yesterday's work. Okay, there's your hint for that. Okay. 7 is a wee mixture. You're going to have to use your UVAST equations, or A equals V minus U over T to get that there. And then that'll be F equals ma. 8 is another one which is quite like question 6 and like, I think the first question, yeah, question 1 from yesterday. So I'm not going to draw out all the hints here. Let's see if you can get that one. Okay, and then 9 and 10 are a wee mixture of using your A equals V minus U over T and then F equals ma. I will let you tackle those yourselves. Okay, that is me for today. I look forward to seeing your answers in those ones. Bye.